Hi, my name is Pasquel from Wolfram Research, South America. Today I'm presenting Surfing the Blockchains, a live coding experience. So stay tuned.
Thank you very much for coming. So before starting, I have to tell you that if you want to interact with some part of my presentation, you want to have a QR code scanner on your cell phone. So I'll give you a minute to download it. So in the meantime, so everyone has like a nice template. I don't have that, so I'm just writing my name there. Christian Pasquel from Wolfram Research, South America. Our team is mainly based in Lima, Peru. So while you download your app, so today I'm going to present you some cool stuff we do with blockchain and our technology. And I'll show you who is responsible for all this. So we have, in the blockchain team, we have Piero, Akira-san, and Daniel. We also have the integrated services team, Erasmo and Juan. We also have our cryptography wizards. So that's Daria and Konstantin. Also, so we wouldn't be able to do anything without our lovely assistant project manager, Carla Santana. And of course, our manager, Johan, who's going to give a presentation after this one. So stay in the room. It's going to be mind-blowing. And he doesn't like pictures, and I totally respect that. So I got for him the only and the best, Leo Messi. Yeah. All right, so are you ready? Let's start with this. All right, so we'll start with some general information about blockchain. So we try to make our functions intuitive enough so you can understand from the name what you are doing. So let's do something like this, blockchain data. Let's point this to the Bitcoin blockchain. And here you should be able to see some current information of the Bitcoin network. See like the current number of blocks, the latest hash. We have something very cool that not everyone has, which is the a connection to the testnet network. Hope this works. All right. And so I can do the same thing with Ethereum. So currently we're only supporting Ethereum and Bitcoin, but we're working on supporting more blockchains. So just to warm up, let's play a little bit with this data here. So we try to provide all this as computational data. So I don't know, let's make some cool list plot with this. So let's look up for here. Let's take the lowest gas price. These are just some useful Ethereum stats. And this is just a very, very basic example. So, but the idea is you can you can use all this data to do like cool stuff. So, for example, here I have a very simple list plot of all these stats. All right, so let's go a little bit deeper and let's explore the blocks. So, so I have the blockchain block function, blockchain block data function, which is going to get information about a specific block. In this case, I'm going to get the latest block of the Bitcoin blockchain. Let me present this as a data set here. All right, so here you have basically all the information you get in a block header and more. So you have like the transaction list, the time when this block was mined. Let's try the same with Ethereum. Let me change this. This should work. All right. So we can do the same with both Bitcoin and Ethereum. So one very cool thing about the Wolfram language is that it knows about the real world. So let's say I'm going to get the byte count. So the byte count is basically the size of the block. So these are bytes, and I can use the quantity function to assign units to this. So these are bytes. So if I do now like a unit convert of these, let's say we'll do megabytes, I should now get the result in megabytes. All right, so let's play a little bit more with this. So I have this functional plan to submit to the function repository. Bob and Harry showed that yesterday. All right, so let's try with the Bitcoin block and an Ethereum block. So this is just like a visual comparison. So you can actually, do you see like a small red dot here? Let's just get another block. It's going to look better. Well, it's super small. Actually, let's try this with a Bitcoin testnet. That one has smaller blocks. So let's try this. Blockchain base goes to, we're gonna do Bitcoin testnet here. Let's extract the byte count. So I'm comparing the sizes between the Ethereum and a Bitcoin block. So the red one here is the Ethereum one. All right, so let's go even deeper and let's explore some transactions. So we had this Bitcoin block here that has a transaction list, right? So what I'm doing here, I'm going to remove the Coinbase transaction, and then I'm gonna do a random choice so we get any random transaction from here. We'll set transaction ID. Let me save this as Bitcoin transaction ID, all right? And let's do blockchain transaction. So we have the blockchain transaction data, which, as you may guess, is to extract data from the transaction. And let's stick right now to with the Bitcoin blockchain. So the blockchain-based option and the dollar blockchain-based variable is very similar to the cloud-based. If you are familiar with those functions, you're going to probably understand how this works. Right, so let's try. All right, so I get a lot of information from this transaction here. So let's explore, let's say, the outputs. The outputs are interesting, because you can see here, for example, here we have a standard pay to public key hash script. Here I see one pay to script hash script. So we are working on getting all the information we can from the blockchains. And not only that, and this is like super useful for educational purposes, because we even use our own technology to learn about this blockchain. So we are working on adding more blockchains to our language, and like the development cycle starts with learning and researching about these blockchains. So we're probably not going to have this in the next release, but probably on 12.1, we are working on a Bitcoin script interpreter, so you'll be able to run this code in Wolfram language and get a symbolic representation of all this. All right, so another cool thing. So I was telling you before about how the Wolfram language knows about the real world. So remember we had, let's put this as a data set. So let's say this transaction here has these total Bitcoins that were transacted here. So let's extract this. And the Wolfram language knows, let's do full form this. The Wolfram language knows that these are Bitcoins. So I can do something like currency convert of these Bitcoins to, let's say, US dollars. So I should get the actual value in US dollars. We have another property that is called the fee. That's a fee included in the transaction to be awarded to the miners. So let's try here with the fee. and a more exotic currency like Peruvian soles. All right, you can get some cookies with that in Peru. And we can even do currency convert between cryptocurrencies. So I hope this works. We're going to convert this into ripples. Yeah, so here's that. That's amazing. All right, so let's do some fun stuff here. I recently learned about the Benford's law. Do you know what's the Benford's law? Well, if you don't know, I'm going to show you a very, very cool function my group developed. It's called Wikipedia Data. Let's try. So with Wikipedia Data, you can extract information from a Wikipedia article. So Benford's law is a distribution, also called the first digit law, where when you take the leading digit, so the first digit of real life data sets, you usually find that the number 1 appears about 30% of the time, number 9 appears about 5% of the time. And you can find this in different data sets like electricity bills, stock prices, house prices, population. And that's another opportunity to show you another amazing function we developed with my group. It's called web image search. So I'll show you how Benford's law, how the distribution looks like. All right, so it looks something like this. So let's do a simple experiment. Let's see if a transaction, if all the transactions in a block follow this distribution. So we have the transaction list here. This law works for all bases. I'm going to use decimal base here because it's easier. So I'm going to convert all these into decimal. Sorry. These here are hex numbers. All right, so I'm going to convert all these into decimal and extract the integer digits. All right, and now I'm going to get just the first numbers and create a histogram. Well, this is just one block. What about if let's do something. Let's create a function that receives a block as an argument. And here we can do blockchain block data block. Let's do blockchain base goes to Bitcoin. I think that's the only thing we need. So let's try this. So have your phones ready because interaction is coming. All right, let's try this. So this is just any block. So what I'm doing here now is I'm going to create a form page that receives a block. There's going to be an integer here. And that's going to use our block variable. And I'm going to cloud deploy this to our cloud. Let's call this cloud and add permissions as public so anyone can use it here. All right, so let me make a barcode image of this. So if you scan this, can you scan this? All right, so you should get, and actually, so I think at one we have another talk about Wolfram in the mobile world with Parth. She'll probably show you more cool stuff, but this should work on your mobile phone. So just play with any block and you should see if it follows this distribution. So if you want to scan this, you have a minute there. All right. Let's talk now about APIs. So I'm going to use this code here. So I think one of the most powerful functions we have is the API function that allows us to expose all this power of the Wolfram language to the world. So let's make a very simple API here. Let's do something like this. So I'm going to use the blockchain block function to get, let's say, the size of the block. So that's a byte count. I'm going to turn this into a string. So I'll add here something like the size of this block is this, and put bytes here, smiley face. Let's call this API test. All right, so I just created an API. So if I go, for example, to my terminal here, so note that I'm not longer using Wolfram language. I'm using a regular bash terminal. So let's try. If I do block 1, 2, 3, 4, 5, 6, yep, I got a result here. So let's live dangerously and try to break this. So that's yet another opportunity to show you an amazing function my group developed called text translation. So let's say we're going to make this API return the result in Italian. Let me deploy this again. And now let's go to, so let's try this from Python. All right, so let's try again with, I don't know, any block. All right, and let's print here the contents. Yeah, I got the result in Italian here. It's amazing. All right. Oh, thank you. So let's play a little bit with cryptography. All right, so we have a very cool function to generate asymmetric key pairs. So I'm going to make one using the elliptic curve Bitcoin uses. Right, so I have now a private key and a public key. So let's try here. Let's get the public key. And if you are familiar with Bitcoin, you probably know about the what's a Bitcoin address. So I'm going to generate a Bitcoin address using this public key. So I'm going to do here the blockchain base goes to Bitcoin. Also, if you are familiar with a testnet, you'll see if I use a testnet here, I get an address with the structure you find in testnet. Okay, so I'm going to save the address here. That's number 72. All right, I have an address here. I'm going to create a barcode image of this. So that's the address. Secure code. And I'm going to show you yet another amazing function my team developed called send message. So I'm going to send this QR code to my cell phone. Well, I hope this works. All right. So if I do this, and if I go to my cell phone here, I should get the result. Yeah, here. It's amazing. All right. So just one more thing, I'd like to call this the bonus track, because if it works, it's going to be an actual track. So we had this, so we had the block here, right? We had a transaction list. Right, so we're gonna do something crazy here. So let's take all these transaction IDs and let's convert them. So let's get the ASCII code of each character. So I'm gonna do the character code. All right, and from here, let's just take, let's flatten this list first. All right, let's take just, I don't know, 100 of this. Let me tune this down a little bit. And all right, so I got the ASCII codes, and I'm going to play with these. So I'm going to create a sound node with each of these. So let's get the sound node here, play it a little bit with the Tempanada crazy instrument. Right, so if this works, I should get a sound object. And actually, I just learned that thanks to Shadi's amazing team, we can do very cool stuff with audio. So let's try to, I just learned about the audio pitch shift function. So let's shift this to this. Let's add some reverb, maybe. Audio reverb, let's use the small hole effect. And finally, an audio delay. 0.5, 0.5. Oh, all right. Well, seems it's working. So, well, I've never had a chance before to dedicate a song to anyone, like on stage. So I'm taking the chance. I'm going to dedicate this song to my good friend, Giulio Alessandrini, who's in the audience right now. All right, so let's hear how a Bitcoin block sounds like. All right, so I'm going to share with you guys, so you can play this. You can play with this on your phone. I hope this works. It's probably going to break a lot with some blocks, but anyway, so I'm going to cloud deploy this, and this should actually work from your mobile phone. Let me call this Bitcoin Sounds. Add permissions as public. All right, and well, let me know if this works. So if you scan this here, well, play with that. I will try with blocks over 200,000. Yes. Like this. Well, it's working. All right. Yeah, and you can also like follow me on Instagram and Twitter using this handle. And well, we had fun. Thank you.